Hey everyone, so the lesson today is about what's called intercept form of a quadratic. We've learned about standard form and about vertex form, but today we're going to learn about the last form of a quadratic, which is called intercept form. Now this is basically factored form day 2 because intercept form is actually in some textbooks called factored form, and it will look very familiar to you. There just may be something extra to it besides just regular factoring. Okay, so factored form is the following. F of x equal to a times x minus p times x minus q. Now you notice there are two sets of parentheses in there. Those are your factors. So factored form is going to help us immediately know where our solutions are, because we know that the solutions are the opposites of the letters that are inside those factored forms. The opposite of P and the opposite of Q. That's what we learned last time, that solutions and factors are opposites. So there's a whole format for a quadratic that looks a lot like vertex form and standard form, with the a value that's sitting in the front of the first parentheses, but this time it doesn't tell you the vertex, it tells you the Roxwords or the intercepts. Okay? So the sort of things we're going to see in these types of problems is something like this. If we're given g of x equal to negative 2, x minus 5, x plus 3, then automatically we know that the roots, zeros, x-intercepts, and solutions, those are my Roxwords, all four of those vocabulary words for this function occur at the opposite of the numbers that are inside the parentheses. The opposite of negative 5 is 5, and the opposite of positive 3 is negative 3. From the zero product property that we learned about last time, those opposites are the solutions, which is also the roots, the x-intercepts, and the zeros. Now we know this because of intercept form, which is negative 2 for the a value times x minus 5 and x plus 3. Yes, I'm just having you rewrite it in this sentence. Eventually, you're going to have to do some work before we can write that sentence. Okay, so again, this is really simple. You're given intercept form, and we're going to ask you for the roots, solutions, x-intercepts, and zeros. Okay, the Roxwords. You just have to tell me the opposites of the factored form, which is what we did last time. Okay, so let's look at number 1. Given the equation, describe the rocks, the roots, zeros, x-intercepts, and solutions. It says the first function, g of x, is equal to negative 3 times x minus 2, x minus 3. So we know that the roots, zeros, x-intercepts, and solutions are the opposites of the factored form, so this particular function is going to have x-intercepts at 2 and at 3 because of this intercept form, negative 3, x minus 2, x minus 3. That's exactly what intercept form tells me. It also tells me that this is going to be a sad parabola because it's a negative. It also tells me that it's going to be a vertical stretch because that a is a Dolly Parton fraction. We don't 100% need to know that. I'm just letting you know that that's why the a value is there. It tells us that it's going to be a happy parabola or a sad parabola, and if it's going to be narrow or wide. Pause the video. I want you to try to fill in the answer blanks for number 2 before I do it. That was enough time to pause your video. So now that you've unpaused it and you've tried it, let's see how you did. The second function, g of x, is equal to 1/2 x minus 5, x plus 9. The roots, zeros, x-intercepts, and solutions of this function occur at positive 5 and negative 9 because of the function or the intercept form or factored form that we see right there. That's exactly where the roots, zeros, x-intercepts, and solutions, where this graph will cross the x-axis for each one of these functions. Really super simple. On the inside of the notes, you have a problem right here, number 3. Now, number 3 is not written yet in intercept form. If you notice, this is written in standard form, which means that we have an A, a B, and a C. Now, if we want to get it into factored form so that we can talk about the roots, zeros, x-intercepts, and solutions, all that we'd have to do is factor this. To factor it, we always set up and solve an X puzzle. A times C goes in the top, so that's going to be 1 times 20, that's 20. B goes in the bottom, that's 9. And A's are underneath. Now the factors of 20 that multiply to 20 and add to 9 has to be 4 times 5, because 1 plus 20 is 21, 2 plus 10 is 12, and 4 plus 5, well, that's 9. We play the reducing game and we reduce these fractions, we would get 4 and 5. Which means I know that this g of x function actually factors to x plus 4 and x plus 5. And now that I have it in factored form, I'm going to be able to tell you the roots, zeros, x-intercepts, and solutions. -4 and -5, because I have this function in now intercept form. So when we aren't given this function in intercept form, when we're given the function in standard form, we can factor it to get it in intercept form. And I know it's a little off screen here, so let me scoot up for you. So if we start in standard, we can actually factor it the way we learned to factor, and then have it written in intercept form. Okay, I want you to try number 4 before we move on. Pause the video and try number 4. Alright, again, this function is in standard form. So when I start with standard form, I'm going to be given an A, a B, and a C. If I want to get it into intercept form, because I want to know the roots, zeros, x-intercepts, and solutions, all I have to do is set up and solve an x puzzle. A times C goes in the top, that means -12 is in the top. B is in the bottom, that means 11 goes down here. And then there are 2's underneath. The numbers that multiply to -12 and add to positive 11 consist of this list. Now the only way for the top of the x puzzle to be negative and the bottom to be positive means that the bigger number is going to be positive. It's always the sign of the bottom. Okay, I can't combine 3 and 4 in any way and get 11. I can't combine 2 and 6 in any way and get 11. But I can combine 12 and 1. If I have a positive 12 and a -1, that gives me positive 11. We play the reducing game. This will be 6, and this doesn't reduce, so it'll stay as 1/2. And I'm going to have factored form as x plus 6 and x minus 1/2, which means I'm going to finish that problem by swinging that denominator forward since I'm looking for the factors for factored form. This is going to be x plus 6, 2x minus 1. Okay, well that's the factored form. We know this because that's what it's asking for in intercept form, is its factors. But when we're talking about the roots, the zeros, the x-intercepts, and solution, we're talking about the opposites of the pre-swing number. So this is going to be -6 and positive 1/2. That's where the roots, the zeros, the x-intercepts, and the solutions for this function occur. If you were not sure about how to check your work, if you remember back to the last video, I told you that you can throw these equations from the beginning into Desmos or any other graphing software and watch it graph. This graph should cross the x-axis at -6 and at 1/2 because our roots, zeros, x-intercepts, and solutions are all the same. We've got a question here on your notes. It says, what do factors of a function indicate about its solutions or zeros? So we're talking about the relationship between factors and their solutions. Well, the factors are going to have x minus or plus some number, and your solutions are just going to be a number. We remember that they are related by being opposites. Okay, the factors and the solutions are opposite signs. That's how we know that they're related and how one will give us the other. Speaking of that, let's say we were given a question phrased like this. We want to write a quadratic function in factored or intercept form whose graph satisfies the given conditions. This time I'm not given the equation, I want to write it. So the only thing that I'm told is that the solutions are -4 and 7. Okay, we could label these as P and as Q, since those are what are in my formula, so you know where they go. But it's more easy just to think about the fact that these have to be opposites. If those are the solutions, then my factors are the opposite. X and a +4, X and a -7. You see how these are now opposites when they go back into the parentheses? Factors and solutions are opposites. Factors and zeros are also opposites, because remember, solutions and zeros are part of my rocks words, so they're all going to be the same concept. If we have that the P is -2 and that the Q is 5, then when we put them back into the function, I'm going to name this function G because I feel like it, their factored form should just be the opposite. X +2, X -5. The opposites go inside the function. Go number 7 and number 8, use different words and or give you a graph. Okay, this one is asking you for the roots, and this one gave you x-intercepts. That's actually the same information because roots and x-intercepts are a part of my rocks words. So I want you to pause the video right now and try to write an equation for both number 7 and number 8. Now remember, for 7, that's a highlighter. P is -3 and Q is 3, which means that the opposites go in the function. I'm going to name this one H. You can name it whatever you want. So when I set up this factored form, it's going to be X and a +3, X and a -3, because these have to change signs whenever they go into the parentheses. Thank you to the zero product property for this. On number 8, you should have done something very similar. You should have noticed that P is -9, because that came from right here. That's where it's crossing the x-axis. And that Q is -2, because it's crossing the x-axis. P and Q are my roots, zeros, x-intercepts, and solutions. So, oh, you can't see what I'm writing because my face is in the way. Hold on. My face. Here I go. Okay, now you can see what I'm writing. So when I write this function, I'll name this one f of x, and I have it in factored or intercept form, I'm just going to use the opposite P and Q than what's on my graph. X +9, X +2. They have to change signs when they go into the factored form. And that's it. We use factored form a lot because it gives us our roots, zeros, x-intercepts, and solutions. Occasionally you'll have an A value, but for the most part you just need to be able to match up if it's a happy or a sad parabola, like this one. This is a sad parabola. So we'll have to make it negative because it's obviously sad. And if it's a stretch or a shrink, we find that out mostly in Algebra 2. So if you know the relationship between factors and zeros, factors and solutions, factors and x-intercepts, they're the opposite, then you've mastered today's lesson. We empower, we impact, we love. We are Skeeter Nation.